Now, this is something that I won't force you to do on a test. If this shows up on a test, this would be an extra credit question. But I want to show you this because this will go into your next couple of years of math. So that's why we're going over this. It's called conjugates. So conjugates, if you look at what I've written here, root 7 plus root 3 times root 7 minus root 3. Conjugates are the exact same thing, except the plus and the minus change. So it's kind of like when we were foiling back in the day, the difference of squares. If you had like x plus 3 times x minus 3, there was a shortcut. And you'll see how the shortcut works again here with conjugates. So if we were to FOIL this out, root 7 times root 7 would be root 49, or regular 7. But let's just write it as root 49 for a second. Then you do your outermost ones. Root 7 times negative root 3 would be negative root 21. Inside, positive root 3 times positive root 7 would be positive root 21. And positive root 3 times negative root 3 would be negative root 9. So let's simplify our stuff. The square root of 49 is 7. Negative root 21 plus root 21, those cancel each other out. So we're left with minus the square root of 9 is 3. And then 7 minus 3 is just regular 4. Now, that's borderline fun, so take it easy. So you use conjugates when there are multiple radicals in the denominator. So remember, we can never have a radical in our final answer in the denominator. So that's where the conjugates come into play. So again, all they do is change the plus and the minus, and then the shortcut is you square the first term. The square root of 7 times the square root of 7 is regular 7. You always make it a minus, and then you square the last term. The square root of 3 times the square root of 3 is regular 3. So let me show you one more example, and then we'll try the problem we have to try. So if we had root 11 plus root 5 times root 11 minus root 5, same thing, one's a plus, one's a minus. You square the first term. Square root of 11 times the square root of 11 is regular 11. You always write a minus, and then you square the last term. The square root of 5 times the square root of 5 is regular 5. And 11 minus 5 is 6. So it's not terrible, but you have to understand what goes into that. So let's try this one here. We have simplify 6 over root 5 minus root 2. I'm going to give myself a little room here. So we have two radicals in the denominator. We're going to multiply by the conjugate. If we have root 5 minus root 2, that means I'm going to multiply by root 5 plus root 2. But if we do that in the denominator, we also have to do it in the numerator. Now, you might want to distribute there. You might want to start multiplying the 6 by both of those things. I understand. I would recommend holding off on that. So let's write it like this. 6 parentheses root 5 plus root 2. We can always do that later if we need to. But let's handle the denominator. We have conjugates. So you square the first term. The square root of 5 times the square root of 5 is regular 5. You always make it a minus, because even if you FOILed it, the last terms would be a positive times a negative. That's why we always write a minus there. You square the last term. Square root of 2 times the square root of 2 is just regular 2. So our denominator came out to 5 minus 2, which is 3. Now the reason I didn't multiply the 6 in yet is because I wait until this step to see if I can simplify this part. Regular 6 divided by regular 3 is 2. So this completely goes away. It becomes a 1, but we don't write the 1. And 3 goes into 6 2 times. So we're left with 2 times root 5 plus root 2. And now we can distribute that. Because again, it was over 1, we just don't write that part. So now we can distribute it, make it 2 root 5 plus 2 root 2. So again, I'm prepping you for the future with that one. If it shows up on a test or quiz, it would be an extra credit style of question. Okay? All right. Yeah.